Hello, my name is Jakov Spirlian, and this is a repeat of my presentation what I held at Aerospace Test and Development Show on the 1st of October 2025. I am from the company Schleißheimer GmbH. We are a small company in Germany focusing on test and test infrastructure. The topic of my presentation is Shift Left, Sustainable E/E testing via Micro HiL Ecosystem. And the first question is why it matters, why to shift left. So what you typically see here is an error curve over time in a development project. And it's obvious if the time is increasing during the development, if you then find an error, the cost to fix this error is much higher than in earlier phases of the project. So what do you need to do? You need to shift left. You need to find failures earlier. But what are the key principles for this earlier finding of the failures? So in our point of view, it's early and frequent testing. So the earlier we test, the more frequent we test, especially in the early phases when there are a lot of changes, the more failures we will find, which we would otherwise find later in the project. So early and frequent testing. The second topic what I have is the topic of how to test on which infrastructure, on a virtual infrastructure or on the real hardware. And what I want to say that it's always a trade-off. You can invest a lot of money in virtualization, but you can not find all errors or all topics which you could find on real hardware. And on the other side, the real hardware is not available at the beginning. So at the end, it's a trade-off of how much to invest in virtualization and when to test on real hardware. Next topic is the parallelization of the development. So if you have a sequential development, you will need much more time to go through the process. So you need to parallelize as much as possible and harmonize the infrastructures as much as possible. And last but not least, and this is also the main point of my presentation, is the left shifting on all integration levels. So at the end, if you remember again the error curve, normally it's like that in the later phases of the development project, you start to test also on the higher levels, on subsystem level or even on system level, and there's much potential to find errors earlier if you are able to test earlier also on these levels. And this is also the main point of my presentation. That's why on the next slide you see here a visualization of the right side of the V model. So starting with software component and software integration test, component testing, subsystem testing, system integration, and system test. So you see here visualized different test infrastructures. And what you see also directly on this picture is that there are really fragmented setups. So this is, from my point of view, one of the main problems when looking onto the setup of test infrastructure, that developers and testers are using different infrastructures, that on the different levels you are using different infrastructures. You are not reusing them. Even between companies, so an OEM and a supplier are maybe testing the same topic on the same level, but each of them has their own infrastructure and they don't fit one to each other. So at the end, this topic of fragmented test infrastructures is creating a lot of friction, and this is the point now. And the second point of these test infrastructures here on hardware level especially is the return on invest. So often we have full grade HILs which are only used for simple test cases, where the question occurs, do we need to build up such a high-end solution here for these test cases? On the other side, it often occurs that HILs are not used that often how they could be used. So if you invest a lot of money in a hardware in the loop system, then it should run 24/7. or at least not 1 hour a day, because at the end it's a question of how much did you invest and how much did you use it. Same for the next topic of the late testing. So it's often like that on these higher integration levels here, the test infrastructure is available really late in the project, and then at the end you are doing some kind of system integration testing. You maybe cover a few releases with it, but you invested a lot of time and a lot of money to create this infrastructure, and at the end you are not using it that often. So that one point is that if you would have it earlier available, then also the return on invest would be much better. And also the last point is relevant. So the reuse of the test infrastructure has influence on the budget, that you don't reuse it. And of course, all of these infrastructures have maintenance cost. So at the end, in summary, these are the two critical issues, or the two challenges. So the fragmented setups, which are creating a lot of friction, and the low return on invest of these solutions. Now I want to go to the next slide. The left part of the slide will be the same, but the right picture will change, because I want to present to you some kind of case study. So what do we have in our location in Wölstadt, Germany? We have a Micro HiL ecosystem. So at the end, we are focusing on small Micro HiL test cages. So what you see here, the cage is a Micro HiL, and we have a lot of them. And the target is that always when we have a development project, when we are working on something, we are integrating the hardware in these Micro HiLs to make it remotely available to our teams. Yeah. So at the end, this is a remote accessible infrastructure, so remote Micro HiLs, with the target that globally distributed teams can work all on the same infrastructure. With this point also comes the topic of high automation. So all of these Micro HiLs are capable for a high degree of automation, to use it in continuous integration, continuous testing process. And at the end, because our strategy is to have a central infrastructure, so it's not distributed anymore. Different locations don't have their infrastructure. They are all using the same one. And this infrastructure is used as efficient as possible. And this is also the reason why we don't need that much prototypes like we need before, for example, because we have just one central infrastructure. So when looking on these points here on the left side, I can say, okay, developers and testers are using here the same infrastructure. So this is somehow covered. And the same for different companies. I have an example from one of our development projects in the past, where an employee of our customer, an engineer from our customer, was sitting in India. He was responsible for base software development, and there was a bug. Yeah. He had not the capabilities to test it on real hardware. He was not able to reconstruct the failure. So what is the solution? The solution would be he should come to Germany and check it here and debug on the real hardware here, or we can send the hardware to India. But our solution was much better, because we just make a common Teams session and debugged it together with him on one of our Micro HiLs, because they are remotely available. So just one example where we could solve a problem within a few hours instead of weeks. The topic of return on invest. So we are focusing on simple solutions. So all of these Micro HiLs are designed to be scalable. This is also the reason why we have so much of them. So we have 96 Micro HiLs in our Micro HiL cluster in Wölstadt, and the focus is to have simple and scalable solution. and not full grade solutions. And this remote infrastructure is leading to the situation that a lot of people are using it from a lot of different locations. So in theory, we can use it 24/7. Of course, it's not like that, but at the end, developers are using it, testers are using it from different locations, and when it's free overnight, the continuous pipeline is using it. So they have a much more effective time than other comparable setups. So these are the points which can be covered by our case study. So what we have now available, and now I want to come to the topics which we don't have available right now, but where we are doing some research on it. And this is what I want to show you on the next slides. So what you see here is an example for an architecture. How is it looking like in the aircraft, for example? So this would be a system here of 40 ECUs. Some of them are larger with a lot of signals, a lot of computing power maybe, and a lot of smaller ECUs with different networks. And the question is now, how much HiL systems, how much test benches do we need to work in such an architecture, to cover this in a development project? And first question, how much HiLs do we need on component level? So when looking on this architecture, let's take the first one. Here's an ECU. We need to test it on component level. So we need one component HiL. Here's the next one. So we need 2. Next one, 3. Next one, 4, 5. And at the end, it's clear. If I'm developing such a complex system, I need to cover all of the components which are available here. I have to build HiLs for them on component level because I need to test them. And now the question is, what about the subsystem and system level? So how much HiLs do we need here? So at the end, what is a subsystem or what is a system? It's depending on your architecture. How is it looking like? And what are the correct interfaces to cut a subsystem, for example, a cabin management system or something else containing of several ECUs which are functionally belonging together. So I make some examples here. So let's say these 5 ECUs here are a subsystem, which makes sense to test it, to test them in such a setup. So 1. Here's another subsystem containing of 4 ECUs, 1 large and 3 smaller. Then another subsystem which is containing of a little bit more ECUs. It could be maybe also a variant of the last one, this one as well. Then some kind of functional use case. So imagine, let's say, a chain of effects, sense, plan, act. So some sensors are detecting something. Something is computed, actors are doing something. So this is some kind of functional use case, let's say, as a subsystem. Here as well a functional use case. And at the end we can continue as before, so that at the end I would say we need maybe 20 HiLs on subsystem and system level, included, let's say, a whole system bench like visualized here, which is covering all ECUs. And now the question occurs, so it's a natural question, is this sustainable? And my answer is not. It's not sustainable because you have a lot of double work. You are rebuilding systems of different ECUs where you are not using synergies which could be used, for example, synergies in prototypes or in test equipment. And the same for the question of cost, because you are doing a lot of double work, you are doing also a lot of double investment here. And the same for the question of time. So you need a lot of time to build all this up. And it's like in typical development projects that in this situation, often this higher level test infrastructure is late available in the project. So this is the reason why we currently have a research project where we do some research on the study on the topic of software-defined bus networks. So at the end, our strategy is to say we don't need so much subsystem HiLs or system HiLs at the end. because we are focusing on component hills. So we want to make everything available in component hills. This could be via our Micro HiL cluster, for example, but this could be also other typical hills. And then say, let's reuse the component hills to build up subsystems and systems out of it. So don't build up dedicated subsystem hills, use the component hills and connect them with each other. And the key element to do this is something what we call software-defined bus networks, or at the end it's a dynamic configuration of multiple subsystems via software. So I can say, now today in the morning I'm testing this ECU, and one other developer is working on this one, and so on. And in the afternoon, via dynamic configuration, we connect them together to a subsystem to see if the changes which have been done maybe on this one, if they have any effect also on a higher integration level. So the strategy is to say, focus on component level and then build up the subsystems and systems out of it dynamically. So via software configuration. We are focusing currently on CAN and LIN networks, and what we are also doing is some kind of networking range analysis, because it's always the question, if we are doing a dynamic connection of them, of micro hills or of hills, then the question occurs, how much distance can be in between these test benches? So must it be one next to the other? Can there be 10 meters in between, or 40 meters, or even other locations? So these are currently things where we are working on it. And the target is to say, okay, we don't need 20 anymore, we need maybe 5. So we cannot eliminate the subsystem and system testing at all, but we can strongly reduce it, because we can connect component hills together to find a lot of errors earlier. So we will not find them later in the project when we have a subsystem bench available. We will find them earlier, as soon as we have component level benches available. So this is our target, and this is something where we are currently doing a concept study. And on the next slide, I want to show you what is, let's say, the conclusion of this topic, or the outlook. When you are looking again on the right side of the V model on the different integration levels, the vision is to say, okay, I have a software build, I'm changing something on one ECU, and I want now to cover these different integration levels as fast as possible, to say at the end the potential CI/CD/CT scope, so of a continuous integration, continuous deployment, and continuous testing, it can be covered in theory up to the system integration testing, to say I change something here and then test on all of these levels there. So to find errors as fast as possible, as soon as I've done the change, and not waiting for I don't know, for half of a year until there's happening some testing on a higher level, and then I find a failure which I could even find much earlier. So this topic is to have, let's say, a much more iterative development, and a much higher acceleration of the development, to get earlier feedback and shorter development cycles. This is the one point, accelerate development. And the second point is to maximize the efficiency, to say, okay, we don't need to invest twice or triple budgets in let's say things where we can leverage synergies. Yeah, so let's reuse the prototypes, let's reuse the test equipment, and at the end, let's save cost, let's save time, and let's save resources. Okay, that's it from my side. So now we are not at the exhibition anymore, so you can ignore this topic. But if you are interested to continue the discussion with us, please let me know. Contact us, sales@schleißheimer.de, contact me directly, visit our website, and that's it.